Hello all, this is Kranti Kumar from St. Peter's Engineering College. I'm from Mechanical Department. Today's topic is solid mechanics. So these are the different objectives I'm going to share with this. What are the different types of stresses and types of loads type, and what is stress, and some problems related to stresses. In this unit, I'm going to cover all these topics. First, we need to know what is a stress. A stress is defined as a resistance body offered by member deformed due to the application of external loads. See, there are many types of stresses. For example, I want to bend this steel. So whenever I apply a load on this material, it has some stresses. Internally, there is a deformation. The internal deformation is called stress. So I want to push this steel in this direction. Again, there is some internal deformation takes place. Thus, internal deformation is called stress. If I bend like this, compulsory there will be a stress. So to find out that stress, we need to understand mechanical properties, and that mechanical property is really related to mechanics of solids. So this is my subject. The stress is defined as the resistance offered by member against deformation. Against the deformations. Okay, if I bend this, there is a deformation. Mathematically, we calculate the stress by load by area. How much load we are giving at what area, that is called stress. I hope you understand. And these are the classifications. There are many types of classifications like dead, steady or static load. Depend upon the load we are giving, manner we are giving, that is classification of loads. Stock loads and impact loads according to the effects of produce of members. So these are the very important loads we are giving in our stress. First, tensile load. So materials may be depend upon some loads. If the material is loaded, it have some properties. So if I apply a load on top, it may bend. It may bend. So this is called tensile stress. This is called tensile stress. Similarly, if I apply a load on a material by compressions like springs, all this, if I apply a load, it is called compressive stress. Compressive. Now take an example of shear load. This is a bread. I want to cut this bread into two pieces. Generally, what we do with a knife. We have to cut with this knife by two parts. See, if I apply a load on this bread here, there will be some shearing take place. The shearing place is called shear load. See, the parts are divided, these breads are divided into two pieces. Basically, mainly depends upon this shear load. And next is bending load. See, if I apply a load on this place, definitely it will bend. So this is called a bending load. For every material, these are some loads will affect in this manner. So bending loads. Next is twisting loads. So if I twist it, there may be called some loads, twisting loads. I hope you understand a different types of classification of loads. And next, it acts along the axis of the body and pulling tendency. It acts according to the axis of the body, tending tendency. As I say you, see, this is a load. This is a load we are giving for the materials. Any materials, if I give the load externally, the material will be elongations, is called tensile load. Initially it may be 5 centimeters. After giving the load, it may come to 6 or 7 centimeters. Then it is called tensile load. And what about these compressions? Almost in every place we've seen these compressions. If you observe the train, they have some springs. That springs have some compression loads. The train body is weighted by this compression load. Observe these bikes, cars, everywhere we use almost these springs. These springs have compression strengths. Whenever the load applied in the ground, it will reach to the springs and springs will be safeguard our vehicle. These are compression loads. It act actually axially and pushing tendency produce some degrees of contractions. And next, shearing load. See, it consists of equal and parallel opposite force acting on the surface of the body. As I explained in the bed example, it has some equal and parallel forces. Next, bending loads. This is a very important load we have to learn in this next units. It produces two couples and produces a certain degree of curvature. See, if I apply a load, like this, we use this bending stress. After that, it may bend. The material may be bended. This is called bending load. And twisting load. See, if I apply a load on twisting, it may twist. For any material, definitely have some of these qualities: bending load, twisting load, tensile load, compressive load, and shear load. These are the loads we generally see in this curve. See, these are examples. Tensile load. A material have some tendency to tensile like this. Compression load. This is a material have some compression loads. And shearing loads, twisting loads, torsional loads, and bending loads. Definitely a load will be taken place and it will bend. And next is types of stresses. These are the very important stresses which will cover entire the syllabus, So each topics are very important. Like tensile stresses. What is a tensile stress? So if I apply a load on tensile load, definitely the stresses will be taken place. See, having given a load here of 10 kilonewtons and here 20 kilonewtons to a material, definitely there is a disturbance here. And the material may be bricks. If you take an example of stick, if you give some load, it may break. Similarly, if I give the same experiment on iron, it will not maybe break, but it will take time. This is called tensile stresses. I hope you understand. And next is compressive loads. Compressive stress. See, every material have some stresses. If you apply a load on different places, it has some different stresses. See, the same material applied on a brick. This is a brick. I want to break this brick. So if I apply a load, definitely some cracks will be taken place. This is called compressive stress. Next, shear stress. So equal and opposite. If I apply a load on this shear, there is a equal and opposite stresses take place here. Due to the cutting actions, there will be equal and opposite stresses take place. Tensile load. As you know, tensile load, applied load at area. Applied load at area. I want to stress this iron rod to some extent. We use this tensile load of cross section area. And next is compressive stress. I want to compress. Spring will be compressed. This compressive load by area is called compressive stress. Generally, we refer stress is load per area. Similarly, in all the cases like compressive stress, tensile stress, we use according to that loads. And shear stress, shear load by surface area. Area is common, but stress is different. Shear load, compressive load, tensile stress. The shear load is generally referred as tau. Unit of stress is very important. The unit of stress is in the newtons per meter. Generally, we use load and area. Load is in the newtons and area is in mm square or pascals. So 1 pascal is equal to 1 newton per meter square. Similarly, stress is in the expressed in newtons per mm square. Okay. So before going on into the stress strain, we need to recall all the properties what we learned. First is stress. What is the stress? Internal resisting forces act upon a material by application of load is called stress. And types of stresses: tensile, compressive, bending, twisting and torsion. These are the different stresses. And now we are coming to strain. So stress and strain are the main stress and strain. What is the difference? So generally, after applying a load due to the stress, there may be changes in the dimensions. That changes in the dimension is called strain. See, I want to increase this length from 5 to 6 of a material. So there are two things will happen. If I give the compressive length, it may comes to 4. If I give a tensile load or tensile stress, it may come to 6 mm. The change of length from original length is called strain. I hope you understand. The change of length between previous length to original length is called strain. If the change in the dimensions comes to be longitudinal, as I said it is called a longitudinal strain or simply strain denoted by sigma. This is called strain, sigma. In case if the strain is calculated in the lateral direction, then it is noted as E. I mean, this is a longitudinal strain. Similarly, lateral strain. Lateral strain. So, for the strain definition is change in length to original length is called strain. Change in length to original length is called strain. We need some problems related to this. So we'll go with some simple problems related to strain. See, a steel rod of 20 mm. Steel rod of 20 mm diameter, like this is a steel rod 20 mm diameter. And 600 mm long is subjected to an axial pull load of, see, it is having some load of 40 kilonewtons. Determine stress. So what we have to know? we have to calculate what is the stress. So we already know about the formula. I mean, uh, yeah, what is the strain, what is the stress, load by area. So forget about the formula, just simply remember what we are giving at what area. Load is 40 kilonewtons and we need to calculate this area. Area. Area of an element or material generally in a circular object. See a steel rod. Rod are compulsory in a circular manner. If it is given in diameter, it is in that circular manner. So for circle we have formula called pi by 4 d square. Pi by 4 d square for finding the area of a diameter. So if you substitute this diameter by given 600 mm, pi by 4 diameter 20, 60 and we'll get the area. What we have given, load by area. Load is 440 into 10 to the power of 3 and area. We'll get the stress. If he has the strain, we use other methods. I hope you understand. We'll move for next topic. Summary. Till now we learn different types of stresses, types of loads and types of stresses. Tensile stress. One of the most important tests applied in metallic material is tensile stress. See, in almost every places, the tensile stress is to be conducted. To know the material of the properties, there are some tests to be conducted. See, I want to construct some of the building. We need to know how much load it can bear, how much property it can bear, how much withstand it can be there taking place. So the tensile stress test is conducted on different machines. One of the most important machines is UTM. This universal testing machine is going to test a tensile properties, tensile stress properties. See, this is a UTM machine. In that machine, we'll place some specimen. This is a specimen, like a rod of diameter sum of the rod. What we do, we'll place this rod in these two jaws, jaw 1 and jaw 2. Between these two jaws, we'll fix this specimen. What happens when we apply a load on two directions? It will slowly elongation. The elongation take place for the round diameter of the objects. This test is used to conduct elongations. When it is taking place in elongations, the test is conducted. I hope you understand. This specimen is placed in this machine. Why we are checking the how much load it can bear? See, tensile stress. Next, this is the diagram, very important diagram. Stress and strain. Stress and strain. See, this is a specimen which is placed in that machine. By connecting one of the digital to that machine, digital element to that machine, a graph is shown. A scientist has discovered this graph on from ductile material like steel. If you place this specimen as iron, we got some this graph. In case if you use gold, it may get like this. So gold we may get like this, and some other materials like we have hardest materials also. That hardest material may take like this also. So depend upon the materials, you will get this curve. So let me discuss about this ductile material stress strain curve. The stress strain curve has many variations. So if you understand this property of a material, the tensile stress is to be conducted. The tensile stress is to be conducted. So first we place the material in the machine. We applied some load. Like initially we use some load called 50 or 60. Slowly, if I keep on increasing, the material property will be changes, and we get the fracture after huge amount of the load. That is called tensile stress. Like initially I'm applying 50 kilonewtons, after that 100, later 150, later 20. So this property has changes in this material. That is called stress strain diagram. It's a very important diagram. See here, first applying a load at starting place, we call it as proportionality limit. There is a proportionality limit. What is this proportionality limit? Here stress and strain are equal amount of load is taking place. Proportionality limit. And next is slowly if you keep on increasing the load, there is some deformation. That means here this is a material specimen. I am giving a load. This proportionality limit, there is no changes takes place. Just we are applying a load and loads in two directions. Later on, if you keep on increasing a load, there is some changes. Internal changes take place. That is called yield point. Here, if I release the load, it can't come to the original position. Before that, here, if I release the load, it may come to original position. That is the proportionality and yield point. And if I keep on increasing the load for this material, there is a point called ultimate stress. This is called ultimate stress. I mean, this material can bear ultimately this amount of load. Beyond that, it's going to break, as we've seen in many places. So everything has some limit. For the material also, some have some limit. Gold have some limit, copper has some limit, and mild steel also some limit. This material changes in these properties. And after that, beyond that, if keep on increasing, there may be chance of break. Not a chance, compulsory it will break. That break is called tensile test. I hope you understand. We'll refer once again. I want to test one specimen that is placed in UTM, Universal Testing Machine. That machine will elaborate this graph. No graph will be same like this for all the materials. For different materials, for different properties. Generally, we've seen ductile material is like this. The brittle material is there. Brittle means glass. If I apply a glass test, the graph will be not like this. It may break here only because we use brittle material like cast iron, glass, etc. Next, these are the silent points marked on the curve as shown in figure. proportionality limit, elasticity limit, yield point, ultimate stress, and rupture point. These are the different points we understand by these graphs: proportionality limit, elastic limit, yield point, ultimate stress, rupture, break point. Proportionality limit. If the maximum stress at which stress is in directionally proportional to strain, maximum stress applied directly proportional to strain is called proportionality limit. And elastic limit, it is a maximum stress at which material gone to deformation phase, and after some load applied, if may come to original position, it is called elastic limit. Similarly, yield point is the minimum stress at which specimen is deformed without notable increase. This is called yield point. I already explained you yield point. Ultimate stress. Maximum stress of the material can withstand without fracture under the tensile load. This is called maximum stress. Maximum stress it can bear is called tensile stress. Beyond this D, see, these are the different elongation take place in the ratio of stress, ultimate stress. So mild steel, this is the curve, and cast iron, this is the curve, and this diagram has an importance in the almost all the engineering materials. I hope you understand.